So in Spring Boot GraphQL, there's many different ways of doing pagination, and each offers different capabilities. Now the first kind of easy way of pagination in GraphQL is to just ask for the full list, and that's called a plural. So here you just say, okay, give me all the friends. So you're not actually paginating, you're just saying, give me everything. So that's the weakest form and easiest form of pagination, or of selecting data. I don't really want to call it pagination, but just getting all the data back. Next would be slicing, where you ask for all of the data, but you add an additional argument, and you can say, give me the first two or the last two items. So it's a smaller subset of that data. But what happens when you want to now traverse the data or go through it? Well, this is where it introduces pagination. This is where we introduce pagination to GraphQL and our app. So if you want to just go to the code, I'll link the time below. Otherwise, I'll talk about this for maybe 1 more minute quickly, and then we'll dive into the code. So there's many different ways of specifying a GraphQL API to use pagination. The first and the weakest form would be create your API name, and you say you want the first two, and you want the first two after the actual first two in the data source. So you want number 3 and 4, so that would offset 1 and 2, and then you get the first two of the remaining, so that's 3 and 4. Now that's pretty weak. I'll explain more as I'm coding. The next example is you would say, okay, give me the friend ID, and you want the first two after this friend ID. Now this has downsides as well, because you're now tying your clients on this friends pagination to a friend ID. So what happens if they want to somehow sort by different fields, or you want to change the sort order or the field pagination or whatever it is? It means that the client will actually have to change the value they submit to you in this after, and they're going to have to know about that. We don't want them to know about that. So this is where we introduce the cursor, and the cursor can be thought of as a wrapped after, so a wrapped friend ID. And here, another advantage of using the cursor is you can become an opaque cursor, and it's a really powerful form of pagination, because when a cursor is opaque, it basically means that the client doesn't actually know what the hell's inside it. It's just like a big base64 string of the cursor, and the cursor represents the actual order of that element in the data set on exactly how the client has asked that to be ordered. So again, I'll talk through all this and I'll actually code it to show you guys. It makes more sense. But this is the best form, because it means the UI can change how they paginate, they can change the sort order, they can change the field to order by, and they just need to keep submitting this big cursor that is sent back from the server to the client. The client never has to generate it or submit different fields. So here it agrees that opaque cursors are the most powerful form and also offer the most flexibility in your API for future changes. So they suggest base16 for encoding them. Now this is the problem. Where does the cursor actually live? So when you create this specification, we're going to be using edges and nodes, and the node will actually contain the data that we're going to return back from that type the user has asked for. And the cursor does not live in there because it's not actually like the business domain. It's not actually whatever it is you're asking back. So this is where we have an edge which wraps many fields. So one is the node containing actual data, and another field is the cursor, which is the cursor that represents this node in the paginated edges response set. So let's dive in, and I'll also talk about the PageInfo and how you can use this to traverse through the future requests. So boom, here we go. Here's our IDE. First thing we want to do is actually create the query. So here we're saying we want bank accounts, and we want to have the user always supply how many they want. So that's known as first. So if we come back here, you'll see first, and then we need an after. So first like this, and we'll say after, and this is optional because if they're on the first query then they don't have an after, and that's going to be a string, or you could have a special let's say a custom scalar if you really want, and you can deserialize that as it's coming in to a certain type. I recommend that, but let's do it in another video as an improvement. And then what you want to return is, it's called, let's say, a bank account connection. And here what we do is we use annotation at connection, and that's going to use relay, and it's going to actually generate the boilerplate and like skeleton GraphQL types, and that allows us to reuse these types and generate them on the fly without having to code like identical classes many times. So this is going to generate the edges types, node types, and the actual connection type, which is the wrapper, let's say, of the them2. And here you say you want the connection for, and we say we want it for the bank account. So here we have a bank account connection at connection. This is going to generate for us, and we're saying it's for bank account, and this actually needs to be in quotes. So now that's it. That's all we have to do in the schema side. And let's hop back to the code. So I prepared a wee in-memory mock demo bank accounts repository, and here I've got two methods: get bank accounts and get bank accounts after. So if you haven't watched my previous video on Duke and the seek pattern and how it's really performance improvement, this is the time maybe you want to go back and look at that for really optimal SQL pagination. Well, this is basically where you would plug the Duke side in, or whatever data source that you want to talk to. So here we're just saying we want the bank accounts after a certain ID. So let's go ahead and create the controller to match this bank accounts type. So here we return a connection of type bank account, and then we have an int of first, and then we have a nullable. So I'm going to use the JetBrains annotation, nullable string, which is going to be the cursor. And here we implement the GraphQL.relay connection. And here you can see it has get edges and get PageInfo, and that's based on the relay specification. And you can read about it here on the Facebook IO, GitHub IO website. So in here, let's go ahead and actually implement this. So the first iteration we'll do now, we're going to ignore the cursor, and then we'll add the cursor in the second round. So what we want to do is actually inject the bank account repository here. So now we have access to that. And then here we say we're going to get all the bank accounts. And once we get all of the bank accounts, we need to stream them, and let's map them. And what do we need to map them to? We need to map them to edges. So let's go ahead and create the edge. So there's a default edge class provided by relay, and that's going to contain the node and the cursor. So it's going to be one of these elements. So we come back, we say we want the default edge. The first parameter is node and the second is connection cursor. So here the bank account will be the node, and then the connection cursor, what is that? We haven't created that yet. So go ahead and create a new package, and it's called connection. I'm going to call this, let's just call it cursor util for now. and I'll make this another bean. And inside the cursor util, what we want is a method that will return a connection cursor. And the connection cursor is created. There's one default connection cursor that we pass in a non-null or non-empty string. And we want to create that from, it's going to be an ID. So we can say from, and then the ID. And here, this is where we actually will base 64 encode the string to make it opaque, so the client does not actually understand it. So we get the encoder, and yeah, that's encode to string. And then we want to get the two strings, the string representation, and then get bytes, and then get standard charset UTF-8. Now once we have that, we can then return a new default connection cursor with downside, and that's our connection cursor for each node. So cursor util from bank account.getID, and then we can optimize this so we can return. So now we have a list of edges, and actually we need to collect that. So as you see here, we have a list of default edges. So this is going to be the edges. And then what we actually need to return is a default connection. And edges is the first parameter. And the second is going to be a PageInfo. And this contains the StartCursor, EndCursor, and if the result has a previous page or if the result has a next page. So let's go ahead and add that. So the PageInfo, let's say, okay, new default PageInfo, and we need the first cursor and last cursor. So inside here, let's create two new methods. So connection cursor, get first cursor from, and let's pop that in there. This should really be any type. So let's make that method level generics, and then we're gonna say if edges dot is empty. So if it's empty, we can return null here because you can't return empty string. Otherwise, we return edges dot get edges dot size -1. So we get sorry, that's the last I was doing there. So we get last cursor from edges dot get size -1 edges dot get 0. So it's going to contain the type dot get cursor. Okay, so now we have the first cursor, and now we have the last cursor in our sets. So we can say cursor util dot get first cursor from edges, get last cursor from edges, and here we pop in the first and the last. so, and then we need to actually say, okay, does it have a previous page? Does it have a next page? Now, in a real implementation, you can actually perform the queries or maybe optimize the original query to return this. But since this is a demo, let's just say if it has a previous page, let's just say if cursor is not null, then it has a previous page. So if cursor is not equal to null, it has a previous page. And if it has a next page, let's just say if the edges dot size is greater than or equal to the amount they asked for. So maybe we have more, or if it's on the exact number that they're on, then they don't. So I think that's good enough for this demo. So I pop the page info in here, and boom, bingo, that's it. First iteration of our pagination attempt. Let's just pop this down. Boom, boom, boom. And let's run this and see where I went wrong. So what did I miss? Nothing. Okay. So go back to playground. Let's remove this. Okay, so here we go. This is it. So let's say created add ID. Let's get the currency as well. So here you can see that now this replicates this edges, node, and cursor. Edges, node, and cursor. And you can see that the cursor is returned, and the cursor is a base 64 encoding of the unique ID that represents the edges. And it's very important that it is unique so that you can correctly offset and you do not have missing data. Again, please watch my last video on SQL pagination with the seek method, and I explain the pitfalls of not doing this correctly. So here, this is the nice pagination. If you want the first two, then I need to perform a limit. So this is going to be we need to optimize. So let's go ahead and say, give me the first two. So here we say get bank accounts, and we stream. And here, and because it's here, we can just write limit max size 2. So we stop that. We can rerun that. Like so. And now we want to do is introduce the offset. This is going to be the after parameter, and let's go ahead and actually get all of them first. So we want to use this guy. So what we want is just these two. Now of course it isn't implemented yet, so you're going to get everything back. Now let's actually put this in code. And as you can see, our client, they don't know what the heck this is, so they're shielded. If we change pagination, or if they change it on the screen and they make their first request, they just get the cursor back and they can take the cursor and put it in. So their pagination is really stupid, which is really good. It's the most simplest form. So in our code, let's go ahead and make this change. So we're going to say cursor is nullable. So if cursor equals null, then we want to get all the bank accounts. Otherwise, I'll put this in another method. Let's say bank account. So say cursor, if cursor is not, if cursor is null, return them all. Otherwise, get bank accounts after cursor util from ID, and that's actually going to create the cursor. So now we need to reverse it. So create cursor from string. This is going to be UID, and we can remove this. So we say base64.get decoder, and then we say decode. So we need to get the bytes from the string. Actually, I don't think we do. I think it offers the method. Yep. So get the string, and then we need to actually create a UID from that string. So UID dot from string, and then yeah, of course we need to create the actual string from the bytes. So cursor util, so decode say create cursor with ID, decode cursor with, so let's say cursor decode cursor with the ID. Oh, it's going to be called cursor. Decode cursor. Now that returns the bank accounts, so you can say bank accounts cursor. Delete that dude. Copy that there. Save that. And let's replay that. So we should get NDE and NDH. So NDE and NDH. So that's how we can use the connection cursor. And if we want to get the last one, we paste that in, and here you can see it's NDE, NDH, and start and end. And then this is just one, which is going to be one start and end. And then of course you can pop that out, get all bank accounts, and then you can say, okay, I want to get these two, but I just want one. So it's just the next one. You can say you want 2, NDE and NDH, or if you want 5, then it's going to have next page is false. Okay guys, so I hope you guys enjoyed that. I rushed through that, but I hope that you can use the video to pause and actually see the methods and the theory, and please try it by yourself. Go and read the documentation and have a lot of fun, and I'll see you next video.